All right, we're back with some more alternating series. On example 4, we want to approximate this series, the summation from n equals 1 to infinity, negative 1 to the n plus 1, over 1 over n factorial by its first 6 terms. Then calculate the remainder of the approximation. In other words, we want to know how far off could we possibly be? What's left over? We're going up to 6 terms. That's not exactly how big the whole sum is. How far off could we possibly be? And we'll use the alternating series remainder in order to figure that out. Okay, so let's come back over here and look at this particular example. And my first 6 terms. Let's just write out what those terms are going to look like here. Sum n equals 1 to infinity. No, actually, I want 6 terms, so I'm just going to go up to 6 right there. Negative 1 to the n plus 1, 1 over n factorial is equal to, I'm starting with 1. If I stick 1 in for the exponent, that makes it a 2, which means our first term is going to be positive. Okay, so it's a positive 1. And then times 1 over 1 factorial, and I'll just keep it like that, 1 over 1 factorial. And now they're going to alternate. The next one's going to be negative, because I'll stick in 2. 2 plus 1 is 3. Negative 1 to the third power, it's negative. 1 over 2 factorial, plus 1 over 3 factorial, minus 1 over 4 factorial, plus 1 over 5 factorial, minus 1 over 6 factorial. Whatever that approximates to, that's where the calculator is going to come in handy for sure. And you know what? I'm just going to get a blank one. Yeah, there we go. So I do have a little summation. I have a little summation button that's right over here. And it puts an obnoxiously large sigma there. And I'm going to start with n equaling 1. And then go up here, not to infinity, but just to 6. And then inside here, we want to put our sequence. And I can do this with a little fraction bar thingy. And it was in parentheses, negative 1. Get out of the parentheses here and raise that to the nth power. And then go down here to the bottom and make that n factorial. And then let's hit enter on that one. Oh, wait a minute. I think the exponent on this was supposed to be n. That's a negative. It should have been positive. All right, so copy and paste it, and this exponent is wrong. The exponent, was it? I think it was n plus 1. Yeah, that's what it is. So plus 1. Enter. Okay, that's better. That's better. All right, so 91 over 144. Then. Okay, so we're saying that the sum of our series, S, is approximately equal to S sub 6. We just added up the first 6 terms, which is 91 over 144. But we could be off, right? We're definitely off because there's an infinite number of terms that came after it that we're adding and subtracting more and more of these terms. And what we're saying is that if I were to subtract S minus S sub 6, take the absolute value of that, that's equal to the absolute value of our remainder, which always has to be less than or equal to the first neglected term. Our first neglected term here is, let's see, what's our first neglected term? It would be the 7th one, which is A sub 7. A sub 7 is, if I were to take the absolute value of it, I can ignore the negative 1 alternator thing and just take 1 over 7 factorial. What the heck is 7 factorial? Well, if you don't know that, the calculator will tell us, which is 5040, of course, which is equal to 1 over 5040. That's pretty small, right? That's tiny. That's how far off we could possibly be from the actual sum of our series. So let me write a couple of things for you that'll be kind of like something you did in Algebra 2, and that is the sum of our series minus the 6th partial sum. If I take the absolute value of that, that is less than or equal to 1 over 5,040. All right, if I were to, this is like a tolerance problem. If I were to take this absolute value inequality and get rid of the absolute value, this is an and inequality. It gets sandwiched in between the positive and negative version of this 1 over 5,040. So I have negative 1 over 5,040 is less than or equal to s minus s sub 6, which is less than or equal to the positive one. Whoa, that's the wrong number. Pulled it off. All right, and then I do have something I can put into s sub 6 right up here, which is the 91 over 144. S minus 91 over 144, which is less than or equal to 1 over 5040. And then if I were to just solve this for s, I can get a bound for how big that sum could possibly be. I'll just add this 91 over 144 to both sides of this in the calculator, of course. So I have, see, a fraction 91 over 144. And I'm going to first subtract it for the left-hand side. So minus 1 divided by 5040. And I get 199 over 315. Maybe I want that as a decimal. I don't know. Let's see. Let's approximate it. So there you go. 0.6317. Okay, that's less than or equal to s, which is less than or equal to, let's do the addition side on the other side. I'm just going to copy and paste this guy. Copy, paste, and let's arrow over and change that, change that to a plus sign. Easy. We get 177 over 280, which, I don't know, does your brain process fractions like that? Mine doesn't. I need a decimal. So let's approximate that right there. 0.6321-ish. Look at that. That's pretty close, right? These alternating series are pretty awesome in that way, that we can approximate them like that. And if I wanted to get closer to the actual sum, if I wanted to squeeze that down even further, I'd just add an extra term to it, or subtract an extra term, or 3. Right? All right. So next video, we're going to take a look at just another one of these examples, kind of wrap the whole thing up in an FRQ style situation.